Okay, so this is our mini flume that we're going to do some examples of turbulence and mixing with flow. And if you look at it up close here, you can see that there's a propeller that goes in there and pushes the water around. And then there's a series of flow collimators that make the flow so it's laminar right here. And then as it comes around the corner, it's moving faster on the outside than the inside. So to even up the flow, we use the flow velocity across it, we use these to do it. And then it's attached to a battery and a controller, which is pulsed. This is also made to be used in the field. We have a more recent version that's a little bit better than that, than for that kind of thing. So the first thing we're going to do is I'm going to take some of this blue food coloring, and put it on the bottom of the chamber, on the floor of the chamber. So just let it spread out on there. So see, we got a blob of dye down there that's spread out and not much flow. And what James is going to just slowly turn up the velocity. And as you can see, the dye is sort of sticking along the bottom. And it's because we have this exponential decrease in water velocity as we get close to the solid surface. And as it works its way up from the surface, you can see the turbulence start forming, but the laminar flow is making the bottom part stay really flat along the bottom and just very slowly creep. And then the no slip zone, the part that's the very closest to the edge of the bottom of the flume, that is basically molecular fusion that has to get the stuff off of there almost. Although there's probably enough turbulence to get down in there a little bit. The next thing we're going to do is, at this low flow, is we've got two objects, and they've been made out of modeling clay, and they're the same mass. I weighed them out on a scale, so they're the same. I'm just going to hold this in here, and again the dye, and we'll see as I release the dye how the turbulence, it's shedding turbulence behind the object. And in contrast, if we take this one, it's getting really blue in there, but that's what happens when you add food dye. If we add this to this, we can see that it's shedding far less turbulence as the dye comes off the back. It's still turbulent though. And this is in contrast to the corn syrup thing that's in the other video, where we have high viscosity and we have zero turbulence. You can also see sort of a skin, that no slip zone and low flow around the object. Some of that blue dye is sort of sticking right around the edge of that object. So this is why fish are fusiform, but you can have microbes that are square, because you can streamline it, high Reynolds number, and it makes a difference. And the last thing we've got is some cladophora, which is a green alga, a filamentous green alga, that's common in flowing in constant water. So if we see this, what's happening here is it's actually being compressed by the flow. And if we turn the flow up more, it should get more compressed. You may loosen it, hold it down. So that's really compressing it down along the bottom. And now if we turn it down the flow again, turn the flow off completely, you'll see that compression of the cladophora is relaxing and it's puffing up. So you can see that might have effects on how water is able to move through the inside of it. And I've actually done experiments that have shown at the highest velocity there's a less exchange with the inside of the cladophora mass because it compresses it down, and the maximum exchange is at intermediate velocity in streams. So that's all for this demonstration.